Welcome to Mongoose channel. Mongoose is a premium TCP/IP network stack with built-in web server, WebSocket, MQTT, TLS, and firmware update functionality. In this video, we'll walk through how to set up remote firmware updates on NXP RW612 microcontrollers. For a complete list of supported over-the-air update architectures, check out the Mongoose documentation. Plug in your Freedom RW612 development board to your workstation. Visit mongoose.ws and open Mongoose Wizard. Start a new project. Select the target directory. Choose the target architecture, Freedom RW612. You can use either Ethernet or Wi-Fi here. Let's go with Wi-Fi. Choose the LED toggle dashboard, then click Finish. In the Settings tab, enable Wi-Fi and enter your Wi-Fi network name and password. Click Generate. This will create a new project in the output directory. All networking code lives in a single directory called Mongoose. Every time we regenerate the project, the contents of this directory get overwritten, so it's best not to modify any files inside Mongoose directly. Start MCU Espresso IDE and import the generated project. Now, let's hook the toggle controls up to the real LEDs. The LED controls in the UI are bound to the LED's HTTP endpoint. For each endpoint, the wizard generates default C handler functions in Mongoose glue.c, which we can override. Copy the LED handlers into main.c and rename the glue prefix to my prefix. In the read function, read the LED state. In the write function, set the LED state. The LED logic levels are inverted on this board, so we flip the value. Finally, make sure to initialize the LED before starting Mongoose. Start the serial console. Then click the debug button to build and flash the firmware. Open the device's IP address in your browser. We can now toggle the LED directly from the UI. Now, let's add the firmware update button to our firmware. Add a panel. Add firmware update button. Adding a firmware update button automatically adds a corresponding HTTP REST endpoint. Click Generate. Rebuild and reflash the project. Now the dashboard shows the update button. Let's make a minor change to the firmware. For example, change the panel background color. Click Generate. For OTA, we need a firmware.bin file, so go into MCU Espresso and enable .bin generation. Then rebuild the project, but don't reflash it. Select the .bin file and wait for the OTA to finish. Once it's done, the dashboard is updated. The same can be done without the UI, but from the command line interface. Make another change to the firmware. Click Generate, rebuild the project. Run the curl command to push the new firmware to the OTA endpoint. Wait for the OTA to complete. The firmware has been updated. This way, the firmware can be updated by the automation tools. We also can update the firmware via the cloud server. Go to Settings, enable MQTT, and enable firmware OTA over MQTT. Set the device ID to something unique, for example D42. Click Generate. Rebuild and refresh the project. Now you can see in the logs that the device has connected to the public HiveMQ MQTT server. Go to mongoose.ws and open the OTA over MQTT page. This is a simple, no dependency page that you can easily plug into your own setup. It loads a firmware.bin file, splits it into chunks, and pushes them to the target device. Just make sure to update the MQTT topics so they match your unique device ID. Make a minor change to the firmware. Rebuild it, but don't refresh it. Load the .bin file. We can see the MQTT message exchange between our page and the device. Wait for the OTA to complete. Now we can see that the device has been updated. Congratulations! We've learned how to hook a web UI up to real hardware and set up remote firmware update on the NXP RW612, both over HTTP and over MQTT. Hit like and subscribe if you found this video useful. Thanks for watching and see you in the next video.